Hey, see Lindelof videos. If you if you haven't figured out by the title of this video, I want to talk about when to use the product rule and when not to. For example, why is this a really good time to use the product rule, while maybe something like this would not be as good of a use of the product rule? X cubed times x squared plus 3x, right? Why is this example, I look at these two and I'm like, yeah, dude, I'm going to use this. I'm going to use product rule on this one. How come I probably wouldn't use it here? Well, my answer is that in the second case, this function down here, this is really, in my opinion, this is a sum and difference rule problem, because I can just algebraically, really quickly, simplify this by using distribution properties. And by doing so, I can just use sum and difference that fast. So doing this as a product rule problem is a colossal waste of my time and yours. So having said that, I'm not going to do that here. But I am going to use it here. And the question is, how are these two things different? Well, what can I do here? I have g of x is equal to square root x times sine x. Are we allowed to multiply this x and this x? Well, of course we're not. This x here is the argument. So we can't. We have something that cannot be simplified further than it is. Therefore, this is a good product rule problem. So having said that, I'm going to start doing the product rule here. And I'm just going to do this. I'm going to start naming these pieces. I'm going to say, I'm going to call this, for convenience sake, I'm going to call this f of x. And I'm going to call this piece over here g of x. And then I'm going to start building a list. I always use lists because I don't want to make any stupid mistakes. So I know that I need f of x. So f of x is equal to square root x. And remember that square root x is the same as x to the 1/2 power, isn't it? I'm just simplifying this. I'm turning a radical into a rational exponent. Why am I doing that? Because I need to take its derivative for the product rule. So the first derivative here is, this is a 1, so 1/2, right? X to the negative 1/2 power. And just for this second, I'm going to leave that alone because I don't really care about that right this second. I'm not going to mess with that. But I am going to keep building it. Remember, I need a g of x, so my g of x is equal to sine x, right? Is equal to sine x. And the first derivative, so I need a g prime at x also, right? And the first derivative of sine x is cosine x, isn't it? Right? So these are the pieces I need because we know that the product rule says this. I'm not going to, I'll do the definition real quick. That the first derivative of f of x times g of x can be restated as f of x times g prime at x plus g of x times f prime at x. All that matters is that you have function, derivative, other function, other derivative, right? So I have that. I'm going to start just putting my pieces in. I have f of x first. So it says that I need my f of x is let's just call it square root x, right? And then I'm going to need an f prime over here, which is 1/2 x to the negative first power, right? I'm just plugging in these values. And I'm going to go back now to my g of x, and it says that g of x is sine x, so that goes here. Sine x times that. This plus sine is this one. And here it says I need a g prime at x, which is cosine x, right? So if we look at this carefully, what we get here is we finally get our derivative, and it's f prime at x is equal to, there's nothing that can be done here, so I'm just going to rewrite it. Square root x times cosine x, right? Plus, and then I guess I am going to clean this up a little bit. So this piece right here cleans up to, what is it, 1 over 2 square roots of x, is that right? Times sine x. Look really quick, there's nothing that can be simplified out, so I'm going to leave it. Hopefully this was helpful. Hopefully you already had some basic understanding of what the product rule is. And hopefully what you got from this is that one thing to do is to build a list, and that's really important. The more important thing to do is, though, to ask yourself, when do I use the product rule? And the answer to that question, I believe, is when you have a function times a function, and it can't be simplified. There's no way to make this simpler. So if there's no way to make this simpler, then this is a good use of product rule, because some other rules are quicker and more expedient, and you're going to need that sometimes in class and also on the AP exam if that's where you're heading with that. So thanks for watching the video. If you have questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks, you guys.